Okay, hello, welcome to another one of my video log recording sessions where I talk about genetic algorithms. In my last video, or rather last night, I talked about the new evolution scheme that I made and went through all the 8 distributions from which I sampled the utility values and the constraint values separately and ran the evolutions ran the evolutions for 10 items, 40 items and 100 items, and I felt that I needed to do some follow-up, like an extra bit of information, which I mentioned last night as well. And this video is just that. So, going over the end of the notebook, general genetic algorithm, beta evo normal 0. I mentioned that this plot doesn't. There is something wrong with this plot. Well, not so wrong, but something could be better or changed, because if you compare this to this peak plateau plot, the slopes aren't as steep as I would like. I also used paint to just bring these two plots, and then what I'm focusing on are these areas or regions, and you'll see that the slopes aren't as high as I would like. And then I mentioned that because this was 40 items and this was 100 items, I may need to increase the number of entities in the population per generation, because here it was 1000 entities in the population, and here it was also 1000. Yeah. So and because we're dealing with more genes here, 2.5 times to be exact, right? Yeah, 2.5 times. And when you have more space to work with, as in the maximum constraint percentage is higher, you just need more entities that would allow for more mutation and more more mutation and more procreation and mutation than after. So more in terms of population. So that's where I started for today, and here it is. So first, since a couple of things before I start, because each of these sections would take about 50 minutes to run, I did, I kind of cut some corners and cheated. I don't want to say cheated, but cut some corners, and I only did the last 3 maximum constraint percentages. So it's 90%, 95%, and 100%, which takes about 20 minutes. Is that right? Oh no, yeah. Which takes about 20 minutes for 2500. So let's just jump to it. So before, I'll just use this. So before, with 1000 entities in the population, the average peak was 8475, and the average plateau was 8004. So that's what we're trying to go up against, make it higher than this. So I first tried with 2000 entities in the population, and ignore these for now. 2000 entities in the population, and then after about 18 minutes I got 8370, 8330, and 8361 for this is the average peak, this is the average plateau, so they'd be higher somewhere here. Okay, and then that was for 2000 entities. Maybe this is for 2000 entities. 2000. And then I thought, since, as I mentioned, that 100 items is 2.5 times more than 40 items, the entities should also be, times 2.5, the number of entities. So 1000 times 2.5 is 2500, 2500 or 2500. So that's what I did. And when I had 2500 entities, it took this much time, about 1200 seconds, so 20 minutes. And when that happened, this is what you get, but this is hard to directly compare. However, these are the values that I got. 8811. Let me just zoom in. 8811 and 8519. So 8811 and 8519 compared to 8475 8004. So this is definitely bigger. So that's good. We have now established that a bigger population for more number of genes would, somewhat ensure that our plots, or the slopes of our plots, would go higher as the maximum constraint percentage goes higher. Good. But wait. One problem here is that there's one problem. This takes longer than this, of course, but now that we have 2500 entities in the population instead of 1000, it just takes even longer. So I need to find a way to fix the population at 1000 entities and yet make these plots go up more, towards the end of the maximum constraint percentage list. So one of the few ways of doing that, I thought, would be to change the numCreate, or change the number that is applied to the population size in order to get the numCreate, or change the new entity percentage, which is how much of the newborns are selected and put in to the world. So if you remember, new entities will be created, and then they are in a list, but not all of these get to be in the established world. Not all of these get to go at the front. Some of these will be picked. If it's 0.5% and there are right now 8 newborns, 4 of them will be picked, but with duplicates. If it's 1.0, 8 of them will be picked, but still again with duplicates. So I'm trying new combinations where the population is still at 1000. I will be trying this down here. So where the population size is still 1000 entities, but the either the num create will be population size times 0.03 or something else, or the new entity percentage is something else other than 0.5. So that's what I did over here. And if you look here, what I did here is I have the population size at 1000, and the num create is population size times 0.075, which is 7.5%. And the new entity percentage, the percentage at which these are selected, with allowing for duplicates, is 0.5, and this is what I got: 9402 and 9051. So that is 9402, was it? And 9051. 9051. So 94 is somewhere here, and 94 is somewhere here, I think. Is it? Yeah, and 9051 is somewhere here. So it's still very high. So that's exactly what I would like to see. But again, these are at the cost of sacrificing entities with low sum utility values. So I'm still sad to be reminded of that. Next up was this is what I did. I calculated num create by multiplying the population size, which is 1000, by 0.03. However, what I did was I changed the new entity percentage to 1.0, as in the same number of entities that were created. But doesn't mean all of them will be chosen. It just means that the same number of newborns will be selected, allowing for duplicates. So some newborns may not be selected because they were just unlucky, but some other entity will go instead in that place to match the number of newborns to the number of selected entities. So that's what this means. And in this case, the average average peak level was 9160, and the average plateau level was 8798. Yeah, so this is still better, higher, as you can see. When we have the num create is we have the num create at 0.75% of the population, and new entity percentage at 0.5. But this num create 0.03 times pop size and new entities percentage at 100% is still higher than these two, the very original one, and when we had the population just doubled or 2.5 times, times multiplied by 2 or 2.5. So this is still higher. So adjusting these values just proved to be more effective or even efficient in terms of compute time. Because when you do this, the compute time doesn't change that much. It sometimes even goes, takes shorter. So the next thing I did is, no, not here. So the next thing I did is this. Yeah, so in this case, what I did here is I set the num create at 0.075 times pop size, so that's 7.5 times the population size, which is 75, and then the new entity percentage is set to 100% or 1.0, and this is the result you get: 9712, 9712, and 9519. So this is bigger than all of the previous ones, which tells me that rather than, again, which ensures or tells me again and again that rather than just enlarging the population size for this reason, if I want to save time and resources, I would do better by changing, or rather in this case increasing, the num create, the percentages that I multiplied to the population size when I try to get the num create, and or by changing the new entities percentage. So I think at the end of the day, I think what I do, or which values I choose to adjust, is just my preference, and is just up to me to decide, given the situation that I would be in. But I think taking one of these options, applying one of these things to the other cases, or to future cases, for example, all the other 7 distributions that showed the lack of improvement towards the end of the max constraint percentage, would enhance the plots, or would just make sure that the plots slopes do not fall. They would just keep going up towards the end, as you would expect. And another proof of how that kind of happened is that when I look at the heads for the summed utility plots, the black line is the maximum ever. This is from yesterday. And the red line is the total sum of utility. This plot just tells us that no entity has ever hit the ceiling. It has never equaled the actual maximum, the true maximum that it could get. And as these summed utility plots show for the heads, they never did. They weren't even close. What was the maximum ever? The maximum ever in this case was 9598, when the total sum of utility was 9995, so almost 10,000. So still about 400 to 500 short. However, when I did any one of these, what I got was that it always kind of got it almost always did the maximum ever entity almost always did reach the total sum of utility. In this case it didn't. However, in this case it did. This is what? This is when the num create was pop size times 7.5% and new entity percentage was 0.5. And in this case it also did. Let's see. Num create is pop size times 3% and new entities percentage is at 100%. And oh, in this case it didn't. Okay, that's sad. But it's a lot closer because the maximum ever in this case. Where was I? No, not here. The maximum ever in this case was 9810, so this is still higher than 95 something. And in this case, num create is pop size times 7.5% and new entity percentage is 0.5. We see that the red meet black, or the black dash dotted line met the red line, and they're just completely merged, so we don't see the black line here. And the maximum ever was 9995. Yeah, so it did. And also when num create was 7.5% of the pop size, and the new entities percentage was at 1.0 or 100%. Still same thing. The maximum ever was equal to the total sum of utilities. Yeah, here you go. 9997 6938 9997 6938. So that happened. So by tweaking the num create and the new entities percentage, I can make sure that this doesn't happen. This just faltering doesn't happen. But again, it's also still at the cost of entities with low summed utility values. So that's one thing that I wanted to cover today. And another thing that I wanted to cover last night, or recheck last night, was this phenomenon where when I used the left skewed distribution, all the plots indicated that the evolution just was very similar to when I used the normal distribution, which is quite odd, because this is the distribution that I used previously by doing some maths on the given variable distribution and flipping it in order to make this kind of distribution. But maybe I thought I was doing something wrong, and I tweaked the code in order to get something like this, but still using or utilizing the variable distribution in the code, but by giving some different alpha and beta. Whereas in this case, I gave the same alpha but a different sign, as in I think it was from plus to a minus, and then I added 100 in order to make sure that none of the values were negative. In this case, that's not what I did. What happened is I gave the alpha and beta as 50 and 100 in the variable variate function from the random module, I think. And where is it? That is usually what you get when you sample 10,000 items and get a histogram of that. So I did that because these plots were just too similar to when I used the normal distribution for samplings of the utility values and the constraint values. So here's for 100 items. Here's for 100 items. No, wait. Here's for 100 items, left skewed. Here's for 100 items. Oh, where is it? Here's for 100 items, normal distribution. See, they're almost identical. And 40 items. 40 items, same, almost identical. And 10 items. See the stairs? They're the same. So what I did today was change the code so that I get this instead of this, although there isn't much of a difference, and then run the entire notebook, run a new notebook in its entirety, and see what I get. And this is what I got. This is for 10 items, the peak plateau plot for 10 items. This is the peak plateau plot for 40 items. And this is the peak plateau plot for 100 items, which are exactly the same. There's almost no difference. See? Like, spot the difference there. This is just tiny movements. Other than that, it's the same thing. Yeah. So my conclusion is that when you sample values from something like this, it could be that it, other than, let me just copy this paint. Although these values are, left skewed, they're not like this much left skewed. So I'll need to find another one that does this. But as of now, if I get rid of this part, oops, let me find it. If I get rid of this part, this part, it's almost like a normal distribution. A very sharp one, a very tall one at that, but it's almost like a normal distribution. And that's why it acts like a normal distribution. Because there's so little stuff here. There's a lot of stuff here. Now, one final distribution that I really need is something like this. That's the same. Yeah, something like this. Really left skewed. So I'll need to implement that. However, this means, sadly, or rather unfortunately, this means that I think I need to do that exhaustive, it's not a grid search, but do that exhaustive process again, where I go through all the distributions, namely, what, oh my god, normal, log normal, uniform, what was it, exponential, Mises, Pareto, what's the last one, Fable, and then left skewed, left skewed. Let's just say left skewed, mild, left skewed, extreme, or just very, something like that. So now I have 9 of these. 9 of these, which means that I would have 9 times 9 equals 81 distribution products that I would need to go through and apply the new Evo scheme, including the change to the selector where the equal sign was introduced. Very important. No, not that important. And actually, and maybe not change the num create. So don't change that. Num create is still at 0.03% of the population, and the new entity percentage is still at 0.5. Now that we know that increasing these values will make the plots go even higher, but now that we know, let's just not do that, because I want these values to be fixed for all 10 items, 40 items, and 100 items. So yeah, 81. And I really don't want to spend another $100+ on Google Colab Pro Plus. I don't think it was worth it. So maybe I need to use AWS or Lightning AI. I don't know. I'll look for options. Yeah, so that's about it. Thank you very much. See you next time. Bye.